G'day everybody, where's Wally here. Hey, I was fed this video by the algorithm and it's packed full of little gems. Now this video is 9 months old and I think it is so good it deserves a new life. Now I will play it all here, but Andrew, he did all the work, so please give him a like and a subscribe over on his channel, and the link to his is in the description as always. So sit back and enjoy as Andrew takes Flatzoid apart piece by piece by piece. It's lovely.
Hi, I'm Andrew Johnston, but you might also know me as various incarnations of Limited Angle, Ted Angle, Ed Angle, Eddie Anglo, Edward Anglican. For a while I was the Portuguese-Japanese character Eduardo Igirisu 1 through 6, and more recently I've been the very regal Terry Windsor 1 through 8. Today I'm tackling Flatzoid's 27 questions the globe defenders can't answer. Now, many of these questions are malformed, nonsensical, stem from ignorance, or contain unsubstantiated claims. But here goes anyway. Question 1. Latitude lines. How are they derived? Are they taken from elevation angles that require a 90-degree flat baseline? Well, these days we use GPS satellites whose locations are so well known that we are able to determine our position in 3D space to sub-centimetre precision. But in the past it was done by observing the meridian transit of celestial objects. Now, once enough locations have been measured astronomically, intervening locations can be determined by regular surveying methods. Now, the second part of the question has a false assertion and a poor understanding of geometry. Now, because refraction increases and gets more variable at lower angular elevations, for astronomical determinations of latitude and longitude, it's best to make the observations of objects that are close to the zenith and measure the angles down from the zenith rather than upwards from horizontal. Hence, transit instruments were once widely used to compile star charts and determine locations in surveying. Now, I have no idea what a 90-degree flat baseline actually is, but the issue of refracted sightlines comes up in question 8. And the false assertion is that angles require a flat baseline at all. Angles only require a vertex and 2 rays. Question 2. Why, when demonstrated in real life, are the shadows on a sphere not what we observe when looking at the real moon? Well, to answer this question, I made up a demonstration in real life. I have a globe with a torch behind it projecting the shadow onto a screen. I have a 3D printed moon. And here is me moving the moon into the globe's shadow. Now, for comparison, here is a time-lapse of a total lunar eclipse in 2018 recorded by Griffith Observatory. And here's a screenshot from each of those videos. And just so it's completely obvious, I cropped out the background from behind my moon. And I'd say those shadows look remarkably similar. Question 3. How does your belief in gravity equally nullify all of Earth's different motions and speeds? Now, I'm not really sure what this one is asking. When Flatzoid went over this question, he talked about the different vectors that the Earth moves in, around the Sun, around the Milky Way, towards the Great Attractor. The simple answer is that these vectors add together to produce a resultant vector, and gravity has nothing to do with this. Question 4. Do blerfers understand the difference between globiolis and coriolis? Well, yes, I do understand the difference. Coriolis is the various effects caused by the rotation of the Earth. Now, flat earthers like to create a straw man version where, if it were correct, objects on the equator, for example, should be seen to fly westwards at 1600 kilometers an hour as soon as they are not in contact with the ground. And since that doesn't occur, they declare that the Earth can't be spinning. Like I said, it's a straw man. Question 5. How can level bend with a globe if it is always defined as straight? They're playing dictionary games here. Now, level has many uses. For example, a level playing field. At a local scale, and to the tolerances required for a sports field, we would call it level if it didn't tilt in one direction enough to favour one team. But being more specific, level means having all parts at the same height in relation to something else. And in the context of this discussion, level is considered in relation to the Earth's geoid. So no, it's not defined as being straight. Question 6. How can gas pressure exist without a container, even though no one has ever been able to demonstrate this violation of natural law? The term gas pressure is commonly used to denote gas that is held in a physical container. So by this definition, gas that isn't in a physical container won't be defined as having gas pressure. But really, the question is whether gas molecules can be kept under pressure without the use of a physical container. And yes, they can. The containment doesn't have to be caused by a physical object. Matter can be contained by forces. For example, electromagnetism can be used as a way of containing charged particles. Gravity, however, produces a force that acts on all things with mass or energy. Gas particles in the atmosphere are for the most part prevented from leaving Earth by the force that gravity produces on them. The second part of the question has a false assertion, that the pressure without a container is a violation of natural law. Now, firstly, what natural law? I'm going to presume he's talking about the second law of thermodynamics. In that case, there isn't a problem, because the gas is being held under pressure by force. And if you really want to pick nits, at an atomic level, gas particles don't actually bounce off the matter that the container walls are made of. They're actually repelled by the electromagnetic force interacting between the gas atoms and the wall atoms, so they are already being contained by a force. Question 7. How does a gyroscope precess 15 degrees per hour in free space? In physics, the term free space means a perfect vacuum, but Flatzoid is actually using the term to mean that the gyroscope is not attached to anything and therefore won't precess. And he's actually right about this. But the question really is, why do we see a 15 degree per hour precession on Earth? Well, that's because what we observe as precession is the gyroscope maintaining its orientation while the Earth rotates. It's not moving, we are. Question 8. How do you have a tangent if all lines are bent thanks to refraction? Obviously this is about measuring elevation angles from the horizon and how the light coming from the horizon is curved slightly by refraction as it travels to the observer, and the effect this has on the accuracy of celestial navigation. The short answer is that refraction is accounted for in the dip corrections. In this diagram, the observer's eye is at E. H is the horizontal direction from the observer, T is the tangent to the horizon point the observer thinks they're looking at, but R is the refracted position of the horizon, the direction they're actually looking at. The angle from H to T would be the dip if there was no refraction, and the angle from H to R is the refracted dip angle. The effect of refraction has been measured, modelled, and can be predicted. Taking a fairly high observer height of 25 metres, the geometric dip to the horizon is 9.6 arc minutes, and the refracted dip, as stated in correction tables, is 8.8 arc minutes. So refraction of the horizon will make a 0.8 arc minute difference to the measured angle, which equates to 0.8 nautical miles or 1.5 kilometre error to the calculated position. An observer at just 2 metres will only have their calculated position affected by 0.2 nautical miles or around 370 metres. In the context of celestial navigation, these possible errors are inconsequential and are already accounted for in the dip corrections. Question 9. Why do astronauts require snorkels in a vacuum? Well, to be picky, they're not snorkels in a vacuum, they're snorkels in a spacesuit. The inference here is that astronauts are not in space, but in the pool at the Neutral Buoyancy Lab. The actual problem stems from coolant leaks while on spacewalks, most famously Luca Parmitano in July 2013. Without gravity, the water leaking into his helmet wasn't being pulled downwards, and because of surface tension, it began enveloping his head, and thus he was in danger of drowning in space. The makeshift snorkels were 50 centimetres long and gave the astronauts the option of breathing air sourced from somewhere away from their head, giving them significantly more time to return inside should a leak occur. It's just like this footage of Chris Hadfield wringing out a wet washcloth. The water sticks to his hands instead of dripping off. Now Flatzoid has claimed that this clip is augmented reality. Does he think that the artist also added drops to the camera lens to make it more believable? Question 10. What do you do if there is a leak on the ISS? Well, you fix it. Flat Earthers wanted to suggest that any leak will cause the instant catastrophic failure of the space station. The ISS already has a multitude of extremely small leaks that combine to being a manageable loss of air and at a rate that is slowly increasing. This slow deterioration is a consideration in determining the ongoing operation and the projected end of life of the ISS, given that the first module has now been in orbit for nearly 25 years. Now here's a document which is an analysis of leakage of the space station up to the end of 2011, including this plot with a rolling 6 months average, and this list of current leakage rates in various sections of the station. So it's constantly happening and slowly increasing, and it's being measured. As for a more threatening leak, There's a NASA analysis that suggests a 6mm hole would give 14 hours until cabin pressure reduced to an unsafe level, more than enough time for an emergency evacuation. Note that this depressurization timeframe doesn't factor in being able to close off sections of the station to isolate the leak. Question 11. Why do you need fake ISS and space footage if it is claimed to be real? Well, this is based on the assumption that the footage is fake, and the answer would be that they need to perpetuate the lie. But first, the footage needs to be proven to be fake. And this is the moment where I get to mention Simon Dan's challenge to Level Earth Observer. We're all wondering when Flatzoid is going to pick out all the fakery in the 50-minute ISS tour. Just saying it's fake because space is fake isn't sufficient. You need to show that the footage isn't real. Question 12. What is gravity? Well, according to Wikipedia, gravity is a fundamental interaction which causes mutual attraction between all things with mass or energy. Done. Question 13. What is the cause of gravity? In classical physics, gravity is just an observed phenomenon. There's no explanation given for what causes it. In general relativity, it's the curvature of space-time caused by the uneven distribution of mass. Why the uneven distribution of mass causes space-time to curve is not known. So we don't know what it is, but we know what it does. Question 14. Why is there no scientific hypothesis for gravity if it's claimed to be scientific? Is this asking about the cause of gravity or the effect of gravity? For the cause, see question 13. For the effect, is the question really asking whether gravity can be tested? Well, of course it can, given that, in a Newtonian context, the attractive force caused by gravity is related to mass and the distance between masses. A hypothesis would be that varying the mass and or the distance between the masses in an experiment would vary the force produced. It's very simple. Question 15. Why can't you validate Earth's rotation scientifically? Now this has an assumption that the rotation hasn't been validated scientifically, which of course it has. Mechanical gyroscopes and focal pendulums are the two simple ways of demonstrating it, and with higher precision measurements, the variation in gravitational acceleration by latitude can be seen to match the predictions of a rotating globe. There's no shortages of ways to validate Earth's rotation scientifically. Question 16. Why no stellar parallax? Well, stellar parallax definitely does occur despite Flatzoid's denial. In what is known as annual parallax, the closest stars appear to shift in relation to the further ones due to Earth's orbit around the Sun. The movements are small enough that the first measurements were only obtained in the 1830s. Until the advent of astrophotography around the turn of the 20th century, only about 100 parallaxes had been measured. Fast forward to the 1990s, and the Hipparchus mission measured parallax of over 100,000 stars. And even more recently, the Gaia mission, in operation since 2013, has measured the parallax of over 1 billion stars. So sorry, Flatzoid, you're ignorant. Question 17. Can someone isolate some pure gravity? Well, it's a nonsense question, like asking for a bottle of force or a bucket of temperature. Perhaps a flat earther could photograph density for us. In Flatzoid's discussion of this question, he said that gravity would have to be isolated to prove it's the cause of an effect. And actually, he's kind of right about that. The Cavendish experiment setup attempts to remove any other factors that will affect the motion of the masses. Things like temperature variation, air movement, magnetism, electrostatics, and even the Earth's own gravity, so that hopefully it's only the gravitational attraction between the masses that is at play. Question 18. Can you define apparent? Yes, I can. Alright, let's actually have a go at it. Well, the word obviously is based on the word appear, and there's kind of two general meanings. One is obvious, and here's an example. By finding out the educational level achieved by flat earthers, it is readily apparent how they were fooled by the flat earth con. And the other meaning is seemingly real. So, another example. Despite knowing nothing about pseudo-Riemannian manifolds, his constant mentioning of them conveys apparent knowledge. Question 19. What is perspective? It's how something appears from an observer's position. That's all. Question 20. Do you know the difference between optical and physical? Yes, I do. Alright, proper answer. Optics is the branch of physics that studies the behaviour and properties of light. So optical is physical. Now Flatzoid explained that this question really is to do with the horizon, and that an optical horizon isn't a physical one, according to him. Now his own claim is that the Earth is flat, but it's an optical phenomenon that caused the effect of the horizon. He waves around limited angles and diffraction and dust and all sorts of things like that, but doesn't actually provide any models or predictions that match real-world observations. Now, what has been explained to him many times is that the horizon is caused by the physical obstruction of the Earth, and the optical effect of refraction slightly shifts the location that we see it, generally upwards. Question 21. How can we live on a globe if chemistry states that all liquids have a flat top surface despite taking up the shape of their container? Well, what an absolute mishmash of a question. Firstly, chemistry doesn't state that. Physics states that objects will conform to all the forces acting upon them, and gravity is one of those forces. Question 22. Why can I see Venus at night if it's closer to the Sun than the Earth? It's very simple. From Earth, Venus can appear up to 47 degrees away from the Sun, so it will be able to be seen for some of the night. How long after sunrise or before sunset that it can be seen will be determined by the relative locations of Earth and Venus in their orbits, the observer's latitude, and the time of year. Note that this question was devised by Alan Nordstrand, a person who has trouble distinguishing Venus from Capella. Now, Venus is the third brightest natural object in the sky after the Sun and the Moon, and is a -5 magnitude object. Capella, at magnitude 0, is the 10th brightest natural object in the sky, and 100th of the brightness of Venus. So there's no surprise that this question comes from ignorance. Here's a still from Alan's video where he thought he saw Venus in the middle of the night, and a stellarium image of the celestial sphere near Capella. I've marked various patterns in each, and I'll let you make up your mind whether you think they are a match. Alan has recently made his video private. Make of that what you will. Question 23. In 2023, why do you think you live on a ball? Because it's a fact. Question 24. Why do the stars remain the same over thousands of years if the Earth and solar system are moving? Well, they haven't remained the same. Flat Earthers seem unaware of proper motion, which is the observed change in apparent location of the stars in relation to each other from the viewpoint of the Earth. Space is really big, so the angular speeds are quite small. The first proof was by Edmund Halley in 1718, which he achieved by comparing contemporary locations to those recorded by Hipparchus nearly 2,000 years earlier. The first measured, and the fastest known, is Barnard's star, which in 1916 was measured to move at 10 arcseconds per year. A century later, in 2018, the Gaia mission published the proper motions of 1.3 billion stars. So they do move, but not on a scale that will be noticeable to the naked eye over the course of a human lifetime. Question 25. How can we see satellites at night if they're in Earth's shadow? It's the same issue that flat earthers have with understanding why Venus can be seen at night. It's just like how the top of a mountain can be in sunlight while the plains below are in darkness. The mountain type is up above the shadow of Earth's nighttime. The best time to see satellites are near sunrise and sunset. This is when the satellites, which are relatively close to the Earth, are likely to be far enough away to be out of its shadow. Now, the orbit of some satellites don't ever enter the shadow, but those that do can be easily seen to wink in or wink out while they're partway across the sky. Question 26. Where is all the space junk? Well, it's up there and it's being tracked. There's lots of spent boosters and inoperative satellites and lots of other small bits of junk. But space is big and these objects are small. By some estimates, there are 23,000 objects in orbit that are larger than 10 centimetres. So it's there. And finally, question 27. Why no pictures of aeroplanes from the ISS or satellites? Well, the first one doesn't have planes, but it's a spy satellite photo of Moscow in 1970 that I thought was interesting. There's enough detail that when you zoom in, and appropriately I've highlighted it with a red square, you can easily see the queue of people lined up to enter Lenin's mausoleum. So, onto aeroplanes. Here's one of Moscow's airports in 1979. Lots of aeroplanes there. Here's 2 Soviet warplanes on the tarmac in the early 1980s. Here's some more recent ones. A Chinese blimp being attended to at one of their remote desert air bases. Here's 2 photos showing possible damage done to a Russian AWACS plane stationed in the Ukraine. And here's an unidentified new model of long-range Chinese military transport aircraft. Now, there's also planes that get caught in the Google aerial photos, though I can't be sure if they're satellite photos or just airborne camera photos. So I'll move on. Now, we've got pictures of satellites from satellites. We've got Hubble from the shuttle. We've got the shuttle from Mir. We've got Mir from the shuttle. But best of all, and this is really the sort of photo you're looking for, here is a photo taken in 2015 from the ISS of part of the Cayman Islands. It was taken by one of the astronauts aboard the ISS with a handheld consumer-level camera. It's really pretty. But what's this? We zoom in, and we zoom in, and look at that. A plane photographed from the ISS. Mic drop.